Have you ever noticed that the tools designed to give us, like, the absolute most creative freedom are almost universally the most hostile to look at for the very first time?
Oh, absolutely.
Think about walking into a high-end recording studio or standing behind the line at a massive commercial kitchen right before the dinner rush.
Right, there is no friendly greeting there.
Exactly. You are instantly confronted by a wall of knobs, sliders, specialized blades, and heat sources. The immediate psychological reaction isn't, I am going to make a masterpiece.
It's, I am definitely going to break something very expensive.
Yes, you just assume you're going to ruin it all.
It is a phenomenal wall to hit. Interface shock, basically. You are staring at a completely uncompromising environment.
For sure.
The people who built that kitchen or that digital workspace, they just assume you already know the language they're speaking.
Right. They prioritize raw efficiency over approachability.
Exactly. Which leaves the newcomer completely stranded.
Which is a huge problem if you're an ambitious learner trying to build actual career-ready design skills. You have the creative spark, you have the ideas, but there is this massive barrier to entry made of, well, mostly gray panels and microscopic icons.
And that's exactly what we're tackling today.
Yep. Today we are dismantling that barrier. We're going to look at the psychological and the practical first steps of mastering industry-standard creative software.
And specifically, we are focusing on Chapter 01, getting to know the work area.
Yes, from the foundational manual, Adobe Photoshop CC Classroom, in a book 2018.
And our goal here goes way beyond just memorizing keyboard shortcuts, right? Anyone can look up a cheat sheet online.
Exactly. We need to explore the underlying philosophy of the workspace. Like, why did the engineers choose to hide certain tools?
Or why does the application manage your computer's memory in such a specific, seemingly frustrating way?
Right, because if you understand the why behind the design of the software, you stop fighting the interface.
Start manipulating it.
Exactly. We are going to anchor all of these abstract concepts to a practical, recognizable project.
Designing a digital birthday card.
Yeah, it gives us a tangible problem to solve while we decode the environment. But before we cross that threshold, a quick administrative note for those listening.
You definitely want the visual context for this.
You really do. So if you want to actually get your hands dirty and master these exact files and exercises, you can buy the book by scanning the QR code of the book link provided in the description below.
Having that specific visual reference is a massive advantage when you're trying to map out these complex menus.
Oh, 100%. And while you are down there checking the description, I want to explicitly request the audience to follow for more technical design breakdowns and career-building content.
If you're trying to turn that raw creative energy into a sustainable, practical career, hit that follow button.
Okay, let's boot this thing up.
Right out of the gate, the standard operating procedure for starting a new tutorial or new job honestly involves a step that feels strangely destructive.
Destructive how?
Well, before you even look at the welcome screen, you're instructed to start the application and immediately hold down a specific keyboard combination.
Ah, right. Control, Alt, Shift on Windows.
Yep, or Command, Option, Shift on a Mac. And this triggers a prompt asking if you want to delete the Adobe Photoshop settings file.
Okay, I have to challenge this right away. If I'm stepping into a new piece of software, wiping the settings file feels incredibly counterintuitive.
I know, it sounds crazy.
If I spent 3 hours last week painstakingly setting up my custom shortcuts and arranging my color panels exactly how I like them, why is the first piece of advice to nuke it all back to the factory defaults?
It sounds like a recipe for constant frustration.
It really does.
But if you are working in absolute isolation on your own personal laptop, you might not want to do it every time. Consider the reality of a professional career environment, though.
Okay, like an agency.
Exactly. Imagine you get hired at an agency, or you sit down at a shared workstation in a commercial print shop. You open the software, and the senior designer who used the machine before you had completely customized the workspace to fit their highly idiosyncratic workflow.
Oh, I see. So they might have moved the toolbars to the opposite side of the screen?
Or changed the default color spaces, or completely hidden the layers panel. If you don't know how to get back to a neutral state, you are going to waste your first 2 hours on the job just trying to find the eraser.
Wow, yeah. Resetting the preferences clears out all that inherited chaos.
Exactly. It provides a guaranteed, predictable baseline.
Okay, looking at it from the perspective of a shared ecosystem makes it way more understandable. It's kind of like adjusting the seat, the steering wheel, and the mirrors when you get into a rental car.
That's a perfect analogy.
You need to physically reset the environment to a standardized baseline before you try to merge onto the highway. So we hold the keys, we delete that old settings file, and the application finishes loading. And now we are staring at what is known as the Start Workspace.
Which is a fascinating piece of interface evolution, honestly.
How so?
If you look at software from 15 or 20 years ago, booting up a program resulted in a completely empty gray void. The software simply waited passively for you to pull down a menu and tell it what to do.
Just a blank gray box.
Yeah. The modern Start Workspace completely flips that dynamic. It isn't a blank canvas at all. It functions as an active triage center.
You see that immediately with the layout. Right at the top, you have these distinct tabs, primarily Work and Learn.
Right. And in the Work view, there's a central area dedicated to your recent files.
Though because we just reset our preferences to the fact-free default, that list is completely empty right now.
Naturally.
Yeah.
But alongside that, you have direct access nodes to CC files, which is your cloud storage.
And LR Photos, which pulls data straight from Adobe Lightroom.
Think about the paradigm shift that represents for a designer's workflow. It completely obliterates the old boundary between desktop computing and mobile creation.
Oh, right, because a photographer could be on a train, tweaking the exposure of a portrait on their phone using the mobile Lightroom app.
Exactly. And when they get to the studio, sit down at their massive desktop monitor and open Photoshop, that exact portrait is sitting right there in this Start Workspace waiting for them.
It removes all the friction of emailing files to yourself or hunting around on USB drives.
The interface design actively acknowledges that a program like Photoshop no longer exists in a vacuum. It is just one node in a massive, interconnected digital ecosystem.
It's basically anticipating what you are going to do before you even click a button, and that Learn tab takes that anticipation a step further.
It really does. It recognizes the exact interface shock we were talking about earlier.
Right. Instead of leaving a new user to drown in the deep end, it offers step-by-step interactive tutorials directly inside the application frame.
There's even a search bar explicitly built to pull up stock imagery. The entire screen is engineered to collapse the distance between having an idea and actually executing it.
So cool. But to execute our project today, we actually need a file to work on.
Yes, we are going to bypass the recent files and manually open a document named 01end.psd.
This serves as our target, right?
Exactly. It is the final, completed version of the birthday card we are learning to build. It gives us a clear visual reference, a pink rose, blue ribbons, and some stylized text.
Opening that file forces us to confront a fundamental reality about digital design, though.
It really does.
Before we look at where the tools are, we have to understand what the tools are actually manipulating.
There's a massive structural distinction between bitmap digital images and vector graphics.
And if you are entering a creative career, this isn't just trivia. This dictates every decision you make on a canvas.
It is the absolute physics of digital art.
So let's break that down.
Sure. The vast majority of what you do in an application like Photoshop involves bitmapped images, which are also referred to as raster images.
Raster, right.
The easiest way to visualize this is to think of a massive mosaic made out of thousands of tiny, perfectly square, solid-colored tiles.
Like bathroom tiles, basically.
Yeah. When you stand 20 feet back from the mosaic, your eyes blend those rigid squares together to form a smooth, continuous tone image, like a photograph of a rose.
But if you walk right up to that wall and press your nose against the mosaic, the illusion breaks completely.
Totally breaks. You don't see a rose anymore, you just see a harsh grid of individual square tiles.
And those individual tiles are pixels.
Precisely. Now contrast that with a vector graphic.
Right, which isn't made of tiny squares at all.
No, it is constructed entirely out of mathematical formulas. Instead of mapping a grid of colored tiles, a vector uses geometry to plot smooth lines and curves between anchor points.
And the practical implication of that difference is staggering.
It is, because a vector is just pure math. It is infinitely scalable.
So you could draw a vector logo the size of a postage stamp, and then mathematically scale it up to cover the side of a massive skyscraper.
Yeah, the edges of that logo will remain perfectly razor sharp.
But if you take a bitmapped image of a face that was sized for a postage stamp and try to blow it up to the size of a billboard,
it becomes a disaster. Those tiny square pixels just become massive, blocky squares. The image degrades into a blurry, pixelated mess.
wow, yeah. While Photoshop does contain tools for creating vector shapes and typing vector text, its core engine, its primary reason for existing, is the manipulation of those bitmapped pixels.
It is a pixel editor at its heart. Knowing that constraint explains why you can't infinitely enlarge a photograph without losing quality.
And it dictates which tools you reach for when you want to achieve a specific effect. Okay, so we have our bitmapped file open, and the Start workspace melts away, revealing the default workbench.
The interface is dense, but the geography of it is actually highly structured once you know how to read the map.
The layout is highly intentional. Running across the absolute top edge of your screen is the menu bar.
This is the traditional command center. You have your file, edit, image, and layer dropdowns.
Right. This is where the overarching global commands that affect the entire application or the entire document live.
And directly beneath that global menu bar is something far more reactive, the options bar.
We're going to spend a significant amount of time analyzing the options bar later because its behavior is fascinating.
It really is. It isn't static. It physically changes its layout and its readouts depending on which specific tool you currently hold in your digital hand.
So cool. Then anchoring the far left edge of your screen, you have the Tools panel.
This is your literal physical toolbox. It is a long vertical column housing your brushes, your selection lassos, your erasers, and your eyedroppers.
And balancing that out on the far right side of the screen is the territory of panels.
If the left side is for physical action, the right side is for deep management.
Panels are where you organize your complex layer hierarchies, manage your color swatches, and tweak the specific properties of the elements you are creating.
There is a historical quirk regarding how this entire workbench is presented, though, which depends entirely on your operating system.
Oh, yeah. For decades, Windows and Mac environments handle the core philosophy of a workspace completely differently.
On a traditional Windows setup, an application like Photoshop is contained within one massive master window.
Right. If you grab the edge of that outer frame and shrink it, everything inside the canvas, the tools, the panels, scales and moves together as a single cohesive unit.
Whereas the classic Mac operating system embraced a floating philosophy.
Which was so weird.
It was. Your tools were in one small floating window, your document canvas was a separate floating window, and your panels were scattered in other floating windows.
You could actually see your desktop wallpaper or your web browser or your messy desktop folders peeking through the negative space between your Photoshop elements.
Exactly.
I always found that incredibly distracting. Trying to do precise color correction while a bright blue desktop folder is glaring at you through a gap in the interface completely breaks your visual concentration.
Which is exactly why Adobe eventually introduced the application frame to the Mac version, bringing it in line with the contained Windows experience.
The application frame locks the image, the panels, and the menu bar together onto a solid, dark background, blocking out the visual noise of the operating system.
It forces a kind of tunnel vision on the work. But it is vital to know this history, because if you accidentally uncheck Application Frame in the Mac window menu,
your background suddenly vanishes and your tools scatter everywhere.
Yes, a junior designer might panic, thinking they've fundamentally broken the software, when really they've just toggled a 20-year-old interface setting.
Knowing the history prevents the panic. Okay, so we are oriented. We understand the physical layout of the room. But before we can actually edit the pixels of our birthday card, we have to learn how to move around the canvas.
We have to master the mechanics of observation.
That starts with the Tools panel on the left. By default, it presents itself as one incredibly long, single column of icons.
But at the very top of that column, there are two tiny, almost imperceptible arrows. Clicking those arrows immediately collapses the panel into a shorter, double-column layout.
That seems like an incredibly minor detail to focus on right out of the gate. Why bother changing it?
It comes down to screen real estate economics and physical hardware constraints.
Okay, like monitor sizes.
Exactly. If you are sitting at a studio desk with a massive 32-inch 4K monitor, a single long column is perfectly fine. It has plenty of room.
But if you are working on a 13-inch laptop at a coffee shop,
that single column might be taller than your physical screen. The bottom 3 or 4 tools might be completely hidden off the bottom edge of your monitor.
Oh, wow. Hadn't thought of that.
Toggling to a double column condenses the physical footprint of the tools. It is the very first lesson in a core principle. The interface is deeply malleable.
It is expected to mold to your physical setup, not the other way around.
Adapting to the hardware. That makes sense. Within that Tools panel, we need to locate the Zoom tool.
Its icon is universally recognizable, a classic magnifying glass.
You can click it, or you can use the keyboard shortcut, which is just the letter Z.
The moment you select it, your cursor transforms into a magnifying glass containing a tiny plus sign.
The absolute most basic function here is just clicking directly on your image. You click the pink rose in the center of the card, and the software enlarges the image to a preset percentage.
You click again, and it enlarges further, all the way up to an absolutely staggering maximum of 3,200%.
And at 3,200% magnification, the illusion of the photograph is completely shattered.
You are no longer looking at the organic curve of a flower petal. You are staring at massive, abstract blocks of solid color.
You are staring at the individual mosaic tiles we discussed earlier.
To reverse that to zoom back out, you have to modify the tool.
You hold down the Alt key on a Windows machine or the Option key on a Mac. The little plus sign inside your cursor instantly turns into a minus sign.
While holding that modifier key, you click the image and it shrinks. It's functional, but honestly, clicking step by step like that feels incredibly mechanical and slow.
That mechanical stepping was the only way to navigate for a very long time. But interface design eventually caught up to human intuition with a feature called Scrubby Zoom.
Scrubby Zoom, I love that name.
It's great. If you look up at the options bar while the zoom tool is active, you'll see a small checkbox for Scrubby Zoom.
Assuming your computer has a reasonably modern graphics card, this is checked by default.
And Scrubby Zoom completely alters the physical sensation of using the software. Instead of clicking and waiting, you click and hold your mouse button down.
Then you physically drag your mouse to the right, and the image dynamically swells and zooms in towards you.
You drag your mouse to the left, and it smoothly scales back away from you.
The brilliance of Scrubby Zoom lies in how it bridges the gap between the physical world and the digital canvas.
Exactly. It mimics the physical act of grabbing a sheet of paper and pulling it closer to your face to inspect a detail, and then pushing it away to see the whole layout.
You can make a massive sweeping movement to dive into the pixels, or a tiny millimeter adjustment to get the framing exactly right, all in one continuous fluid motion.
It removes the cognitive friction of calculating how many times do I need to click to see this.
It transforms navigation from a math problem into a physical gesture.
But there are times when you don't want a fluid gesture. You want surgical precision.
Let's say you want to look exclusively at the very center cluster of petals on the rose, and you want that specific area to perfectly fill your entire monitor.
If you temporarily disable Scrubby Zoom in the options bar, the zoom tool reverts to a different kind of behavior.
You can click and drag a rectangular box, a marquee, around that specific cluster of petals.
The moment you release your mouse button, the software calculates the exact mathematical percentage required to expand that specific rectangle until it touches the edges of your workspace window.
It's an instant teleport to a specific detail.
But once you are done meticulously editing that center petal, you don't want to manually scrub your way all the way back out.
No, you want to see the whole birthday card again instantly. Up in the options bar, there is a button explicitly labeled Fit Screen.
One click, and the software recalculates the zoom level, snapping the entire document perfectly within the boundaries of your available window space.
Navigation is incredibly powerful, but it introduces a very dangerous psychological trap for a designer.
It really does. When you are zoomed into, say, 800%, editing the microscopic edge of a leaf, you are looking at perhaps 1% of your total canvas.
It is remarkably easy to lose your spatial awareness. You get so hyper-focused on the local detail that you completely lose context of where you are in the grand scheme of the layout.
You essentially get lost in the digital woods.
And the developers knew this would happen, which is why they built a specific safety mechanism. The Navigator panel.
It's usually nestled over on the right side with your other panels, or you can summon it from the window drop-down menu.
The Navigator panel is elegant in its simplicity. It displays a static, miniature thumbnail of your entire unzoomed document.
But the critical piece of information is the bright red rectangular outline sitting on top of that thumbnail.
That red rectangle completely changes the game. It acts exactly like a mini-map in an expansive, open-world video game.
Oh, that's exactly what it is.
When your character is deep inside a complex dungeon, your main screen only shows the immediate walls around you. But you glance up at the corner of your screen to the mini-map, and you see exactly where you are relative to the exit.
That red rectangle on the Navigator panel is your viewport. It represents the precise fraction of the image that is currently being rendered on your massive main canvas.
And it isn't just a passive display, it's a fully interactive control surface.
You can take your mouse, grab that red rectangle inside the tiny navigator panel, and physically drag it to a different part of the thumbnail.
As you move it, your main massive canvas instantly pans to match.
If you are deeply zoomed in and need to check the spelling on a ribbon located at the very top of the document, you don't have to zoom out, pan up, and zoom back in.
You just drag the little red box to the top of the minimap. It saves an immense amount of repetitive navigation.
Okay, so we've mastered the mechanics of observation. We can dive into the pixels, we know where we are, and we can move around instantly.
Now it is time to actually manipulate the data. We need to change how the image fundamentally looks.
The overarching goal here is to brighten the photograph of the rose. It's looking a bit muddy, and a birthday card needs to feel vibrant and punchy.
The mechanics of doing this involve the Layers panel on the right side of the screen. We ensure that our specific rose layer is highlighted and active.
Just above the Layers panel, there is usually the Adjustments panel. We are looking for an icon that resembles a circle divided neatly in half, one side white, one side black.
This is the brightness contrast control.
The moment you click that half and half circle, two distinct things happen simultaneously. First, your Properties panel suddenly populates with two horizontal sliders, one labeled Brightness, one labeled Contrast.
Second, and much more importantly, a brand new layer materializes in your Layers panel. It sits directly on top of the rose layer, and it is automatically named Brightness Contrast 1.
The specific instructions tell us to grab the brightness slider and drag it up to a numerical value of roughly 98 and push the contrast slider to about 18.
As you slide those toggles, the image of the rose vividly brightens on your screen, but focusing on the numbers 98 and 18 misses the entire point of what just happened.
The numbers are totally irrelevant. What matters is the architectural mechanism of that new layer.
This is where we have to talk about the absolute bedrock philosophy of modern digital editing. We are talking about the difference between destructive editing and non-destructive editing.
To understand the gravity of this, you have to look back at how early photo manipulation software operated.
Oh, the dark ages.
Truly. In the early days, if you wanted to brighten a photograph of a rose, you ran a brightness command that fundamentally attacked the pixels of the image itself.
The software executed a mathematical operation that permanently changed the color value of every single tiny square tile in that mosaic.
And the danger there is catastrophic. Let's say you apply that brightness, you save the file, you close the program, and you go to sleep.
You wake up the next morning, open the file, and realize with fresh eyes that you pushed it way too far. The highlights on the petals are completely blown out to pure white.
In a destructive workflow, you are entirely out of luck. The original darker pixel data is gone forever. It was overwritten. You cannot get it back.
You have permanently destroyed the integrity of your base photograph. The only way to fix it is to completely start over from the raw camera file, assuming you still have it.
Which brings us back to what just happened in our Layers panel. Clicking that adjustment icon did not alter a single pixel of the rose photograph.
Instead, it created an adjustment layer. I always visualize an adjustment layer like a sheet of tinted glass.
That's a really good way to think about it.
If you have a printed photograph lying on a table, and you want to see what it looks like if it were brighter and more contrasty, you don't paint directly on the photograph.
You take a perfectly clear piece of glass, you apply a brightening tint to it, and you lay it over the photograph.
That analogy perfectly captures the mechanism. The adjustment layer sits above the image data. It functions purely as a set of mathematical instructions.
It tells the software's rendering engine, when you push the visual data of the rose up to the computer monitor, process it as if it were significantly brighter.
But the underlying code of the rose layer remains utterly pristine and untouched.
You can prove this instantly. Next to that brightness contrast layer in the Layers panel, there is a tiny icon shaped like a human eye.
If you click that eye, the adjustment layer is hidden. The sheet of glass is removed. The rose instantly snaps back to its original dark state.
Click the eye again, the layer activates, and it brightens up. You've maintained total, consequence-free optionality.
Consider the real-world stakes of this workflow in a commercial environment.
Oh, it changes everything. Imagine a high-end advertising agency working on a multi-million-dollar campaign for a new car.
The senior retoucher spends 40 hours meticulously color-correcting the metallic paint of the vehicle, applying dozens of subtle shifts. They present it to the client.
The client looks at it and says, "We love it, but can you make the overall tone just 5% cooler?"
If that retoucher had been working destructively, flattening their edits into the base pixels at every step, that client request is a total disaster.
It means throwing away 40 hours of labor and starting completely from scratch because the previous color data was obliterated.
But if they built those 40 hours of work using a massive stack of non-destructive adjustment layers,
That client request takes about 10 seconds to fulfill. They simply locate the specific color balance adjustment layer, double-click it, drag the slider 5% to the blue side, and hit save.
non-destructive editing isn't just a neat feature, it is the fundamental safety net that makes the modern iteration-heavy design industry physically possible.
It removes the paralyzing fear of making a permanent mistake, which in turn encourages aggressive, creative experimentation.
You can go wild knowing you can always just turn off the layer, but to add a secondary layer of protection, the workflow demands that we execute a save as command.
We do not overwrite 01n.psd. We create a brand new file named 01working.psd.
This ensures that the absolute original state of the project is preserved on the hard drive, completely isolated from our experiments.
Standard operating procedure. Always maintain an unbroken path back to the beginning.
So our rose is looking vibrant, our files are secure, and we are ready to start physically adding graphic elements to the layout to construct the actual birthday card.
We need to create a new ribbon across the bottom to anchor some text. But a professional design requires cohesion.
We can't just pick a random blue. We need the new ribbon to perfectly match the highly specific textured dark blue of the happy birthday graphic that already exists at the top of the card.
We could open the color picker and drag our cursor around the blue spectrum, relying entirely on our biological eyes to guess the right shade.
But human eyes are incredibly subjective and easily fooled by surrounding contrast. Close enough is the hallmark of amateur work. Professional design demands mathematical precision.
To achieve that, we need the eyedropper tool.
But before we even touch the eyedropper, we need to understand where that color information is going to be stored once we capture it.
If you look at the absolute bottom of the Tools panel, you will see two overlapping squares of color. By default, the square sitting on top is pure black, and the square tucked behind it is pure white.
The squares represent the heartbeat of your color engine. The top square is the foreground color. The bottom square is the background color.
The rule is simple. Almost every tool you use to create new pixels, whether you are dragging a digital paintbrush, typing out typography, or generating a geometric shape, will automatically draw its color data from whatever is currently loaded into that foreground square.
So our goal is to get that specific dark blue into the foreground square. We select the eyedropper tool from the panel.
Its icon is literal. It looks exactly like a small glass medical dropper.
We move our cursor over the canvas, hover directly over the existing happy birthday ribbon, and click once.
The software instantly analyzes the precise pixel you clicked, extracts its exact hex code and RGB values, and instantly injects that data into the foreground square.
The top square flips from black to that perfect, identical dark blue. You have successfully sampled reality. You have your paint mixed and ready.
The next step is defining where that paint is allowed to go. If we just grab a brush and start scrubbing across the bottom of the card, we are going to ruin the photograph of the rose.
We need to create a strict boundary. We need to draw the shape of our new ribbon.
For this, we turn to the selection tools, specifically the rectangular marquee tool. In the Tools panel, it is represented by an icon of a square drawn with a dashed line.
The mechanics are simple. You click near the bottom right of the canvas, hold the mouse button, and drag diagonally to drag out a rectangle. The dimensions roughly need to be about 3/4 of an inch tall and maybe 2.5 inches wide, stretching horizontally.
When you release the mouse button, you are introduced to one of the most iconic visual cues in all of software history.
The perimeter of the rectangle you just drew is suddenly outlined by what is universally known in the industry as the marching ants.
It's a fantastic piece of visual feedback. The outline isn't a static black or white line. It is an animated, continuously moving pattern of black and white dashes chasing each other around the perimeter of the shape.
And the reason it's animated is brilliant. If you draw a static white selection line over a photograph of a snowy mountain or a black selection line over a photograph of a dark night sky, the line would instantly camouflage itself.
You wouldn't be able to see what you selected. By forcing the line to animate with high contrast, it guarantees that the boundary remains hyper-visible, regardless of the chaotic colors happening underneath it.
But what is that boundary actually doing? It is establishing a rigid zone of isolation.
I always think of a selection as digital painter's tape.
Oh, that makes perfect sense.
If you are painting the walls of your living room, you spend hours pressing blue painter's tape meticulously around the edges of the window frames and the baseboards.
Once that tape is down, you don't have to be careful anymore. You can take a roller dripping with wall paint and smash it right up against the edge of the window frame, completely confident that the glass is protected.
The marching ants are your digital painter's tape. They create an absolute mathematical barrier. Any pixels inside the marching ants are vulnerable to being edited.
Every single pixel outside the marching ants is completely locked down and impervious to change.
With our digital tape laid down, we can finally paint. We select the brush tool from the panel.
But obviously, brushes come in drastically different shapes and sizes. We need to ensure we have a large, soft brush to fill this area efficiently.
Now, we know from our earlier tour of the workspace that the settings for the tool we are currently holding live way up at the top of the screen in the options bar.
We could drag our mouse all the way up there, click the brush drop down, adjust the size, and then drag our mouse all the way back down to the bottom of the canvas where our rectangle is.
You could, but doing so exposes a massive inefficiency in workflow. This is where we need to introduce the concept of context menus.
Instead of traveling to the options bar, you keep your mouse hovering directly over your rectangular selection, and you simply right-click your mouse. Or, if you are on a Mac with a single button setup, you hold Control and click.
Instantly, a compact, highly focused panel materializes right at the tip of your cursor.
It doesn't contain every single setting in the software. It only contains the specific settings relevant to the brush tool you are holding, primarily size, hardness, and the shape of the brush tip.
We use this pop-up menu to select a soft round brush style, and we bump the size slider up to 65 pixels.
We click anywhere outside the menu to close it, and then we just start dragging our cursor back and forth across our selection.
And because of our digital painter's tape, the experience is incredibly forgiving. You don't need a steady hand. You can furiously scribble way outside the lines of the rectangle.
The dark blue paint perfectly floods the interior of the shape, but the software absolutely refuses to let a single drop of that blue color bleed past the marching ants onto the delicate petals of the rose underneath.
It is deeply satisfying to watch the software enforce that boundary.
But let's pause and analyze that context menu for a second. Why is right-clicking to open a menu right next to your cursor such a monumental concept?
It saves, maybe 2 seconds of dragging your mouse to the top of the screen.
2 seconds sounds trivial in isolation, but let's extrapolate that out. A professional digital painter might change their brush size or opacity 300 or 400 times in a single hour.
They have to drag their mouse to the top of a 30-inch monitor and back down again every single time. Those 2 seconds compound into hours of wasted physical movement over a work week.
It induces physical wrist fatigue.
And it breaks your psychological flow. When you are deeply focused on blending the shadow of a petal, your eyes and your brain are locked onto that specific coordinate on the canvas.
Forcing your eyes to detach, travel across the screen, navigate a complex drop-down menu, and then try to find your exact spot on the canvas again completely shatters your creative concentration. You have to reboot your visual focus every time.
Context menus bring the interface to the work. They allow you to manipulate the environment without ever looking away from the art. It is a masterclass in reducing cognitive friction.
Reducing friction is crucial, but sometimes the software introduces friction intentionally. We have our solid blue rectangle. We need to hit select and deselect to turn off the marching ants.
But right now, it's just a boring, rigid block. To turn it into a ribbon that mimics the graphic at the top of the card, we need to cut a geometric triangular notch out of the left-hand side.
And the tool we need to do that seems to be missing.
We need a tool called the polygonal lasso. But if you scan down the long list of icons in the Tools panel, it isn't there.
You will see the standard lasso tool, which looks like a loop of rope, but no polygonal lasso. This isn't an error. This is the software engineers actively managing your cognitive load.
It's the ultimate balancing act of UI design. An application like Photoshop contains hundreds of highly specialized tools. The engineers want discoverability. They want you to know all these amazing features exist.
But if they gave every single tool its own dedicated square button on the interface, the Tools panel wouldn't just be one column, it would be 5 columns wide and cover a third of your screen.
It would look like the control panel of a commercial airliner. It would be visually paralyzing.
To solve this, the designers use a concept called nesting. They take tools that perform similar conceptual tasks, in this case freehand selection tools, and they group them together, hiding the variations behind one primary representative icon.
But they don't hide them completely. There's a very subtle visual clue. If you look incredibly closely at the bottom right corner of the standard lasso tool icon, you will see a microscopic triangle.
That tiny triangle is the universal interface language for "there is more buried beneath the surface here."
There are multiple ways to excavate those hidden tools. The most intuitive way is to click and hold your mouse button down firmly on that lasso icon.
After a split second, a flyout menu will physically extend out from the toolbar, revealing the standard lasso, the hidden polygonal lasso, and the magnetic lasso.
Or if you want to be faster, you can hold down the Alt key or Option on a Mac and simply click the tool icon.
Every time you click, it cycles to the next hidden tool in the group, swapping the icon out on the toolbar. It's a great way to quickly toggle through your options without dealing with flyout menus.
So we unearth the polygonal lasso tool. The standard lasso we saw originally is designed for organic, free-flowing shapes. You drag it around like a pencil on paper and records every tremor of your hand.
The polygonal lasso operates on completely different physics, doesn't track a drag, it connects points. It is built explicitly for rigid geometry.
We take the polygonal lasso and move to the left edge of our blue rectangle. We click once in the empty space just slightly above and to the left of the rectangle's top corner. That sets our first anchor point. We let go of the mouse button.
As we move the mouse away, the software draws a perfectly straight, taut line extending from that anchor point to our cursor, like pulling a string tight from a pushpin.
We move the cursor directly into the center of the left edge of the blue rectangle and click a second time. A solid, straight line is permanently drawn between click 1 and click 2.
We then move down and click slightly below the bottom left corner of the rectangle for our third point. Finally, we move our cursor all the way back up to our very first starting point.
When you hover over the origin point, a tiny circle appears next to the cursor, indicating that clicking now will close the loop.
We click, the loop closes, and that taut string instantly transforms into our familiar marching ants. We have drawn a perfect triangular selection overlapping the edge of our blue bar.
And then the actual transformation happens. With that area selected, you simply reach up to your physical keyboard and press the delete key.
Instantly, every dark blue pixel that was trapped inside the marching ants of that triangle is obliterated. They are erased back to total transparency.
You drop the selection, and what was a boring flat rectangle just a second ago now has a perfectly crisp, mathematically precise notch sliced out of it. It instantly reads visually as the forked tail of a ribbon.
It is such a fast, aggressive maneuver. It's those moments of instant destructive geometry that make the software feel incredibly powerful. You are curving shapes out of digital space.
So the ribbon graphic is complete. Now it needs to serve its purpose. It needs to hold a name. We need to introduce typography to our birthday card.
We go back to our Tools panel and select the horizontal type tool, which is mercifully easy to find because its icon is just a giant capital letter T.
The instant you click that T, I want you to completely ignore the canvas and look straight up to the options bar at the very top of the screen.
This is the dynamic shift we previewed earlier. It completely reconfigures itself.
Exactly. 5 minutes ago, when we had the brush tool active, the options bar was entirely populated with sliders for brush diameter, hardness, and paint opacity.
The moment the software registers that you are holding the type tool, it realizes brush settings are completely irrelevant to your current intent.
In a split second, it sweeps all of those painting controls away and replaces them with typographical controls. Drop-down menus for font family, font style, point size, paragraph alignment, and anti-aliasing methods.
I always compare the options bar to the digital dashboard cluster in a modern high-end car.
Oh, what's a good one?
If you are cruising down the interstate at 70 miles an hour, the digital screen behind your steering wheel prominently displays your speedometer and your fuel range because that is the critical context.
But the exact moment you shift the transmission into reverse to parallel park, the speedometer vanishes and the screen is instantly replaced by the live feed from the backup camera.
The interface anticipates your context. It aggressively hides irrelevant information to prevent visual clutter, and only surfaces the exact tools you need for the specific physical action you are currently taking.
It is an incredibly sophisticated way of managing complexity. So looking at our newly transformed typographical options bar, we need to set our parameters.
Click the font drop-down and scroll until we find Minion Pro. We set the style to italic. And we need the text to be relatively large to be readable on the ribbon, so we need to set the font size to 32 points.
And setting that number introduces us to yet another fascinating interface quirk. If you want to change the size to 32, you have a few obvious options.
You can click the tiny arrow to open a drop-down list of preset sizes and hunt for 32. Or you can click directly inside the little numerical text box, delete whatever number is in there, and manually type 3 and 2 on your keyboard.
Both work perfectly fine. But the engineers built a third, almost hidden method called a scrubby slider.
The scrubby slider is one of those features that, once you discover it, you will use it constantly for the rest of your career.
If you take your cursor and hover it directly over the actual word size, or over the tiny little T icon sitting right next to the numerical input box, your cursor will suddenly change shape.
It transforms from a standard pointer into a little hand with a pointing index finger, flanked by a double-headed horizontal arrow.
When you see that finger, you click and hold your mouse button down. Now, instead of typing a number, you just drag your mouse to the right.
As you drag, the numerical value inside the box rapidly spins upward, 30, 35, 40, 50. If you drag to the left, the numbers spin rapidly downward.
Earlier, we talked about how scrubby zoom made the act of navigation feel physical rather than mathematical. Scrubby sliders do the exact same thing for numerical values.
When you are designing, you often don't actually know what specific mathematical point size you need. You don't know if 32 or 34 is correct. You just know you want the text to look a little bit bigger.
By dragging the slider left and right, the text on your screen dynamically grows and shrinks in real time. You're dialing in the typography entirely by optical feel, rather than by typing cold number.
It completely bypasses the analytical side of your brain and taps directly into the visual creative side.
It is so much more fluid. Okay, so we've dialed our font size in to roughly 32 points. We take our cursor, we click directly inside the left half of our new blue ribbon, and a blinking text cursor appears.
The cursor signifies that we are actively in text entry mode. The instructions suggest we type the name Elaine.
So we confidently type E-L-A-I-N-E, and immediately we encounter a severe visual problem. We know we typed the letters. We can see the blinking cursor advancing.
But the text is completely invisible. It's not showing up on the screen.
This is a classic trap that catches every single beginner. The text isn't actually invisible, it is perfectly camouflaged.
We have to remember the rule we established earlier. Tools generate new pixels using whatever color is currently loaded into the foreground color square.
And what was the last thing we did with color? We used the eyedropper to sample that deep, dark blue, and we loaded it into the foreground square so we could paint the ribbon.
That dark blue is still sitting there. So the type tool is obediently functioning exactly as designed. It is generating perfectly formed 32-point Minion Pro italic characters using the exact same dark blue color as the dark blue ribbon they're sitting on top of.
Blue text on a blue background vanishes.
To solve this, we need to completely shift our focus. We need to look away from the canvas, away from the tools, and tackle the complex management structures on the right side of our screen.
We have to learn how to tame the panels, change colors retroactively, and most importantly, learn how to recover from inevitable mistakes.
We need to change the color of the text we just typed. We want it to be a bright yellowish orange to contrast against the blue, specifically matching the text on the top ribbon.
We could try to hunt for the eyedropper tool again, sample the top text, and hope it updates our current text layer. But there is a much more robust, standardized way to manage color palettes in a complex document, the swatches panel.
Over in our panel dock on the right, we look for a tab labeled Swatches. If it's buried behind another panel like Color or Libraries, we simply click the Swatches tab to bring it forward to the front of the stack.
The swatches panel is essentially the digital equivalent of a traditional painter's palette, but highly organized. Instead of messy blobs of oil paint, it presents as a neat geometric grid of perfectly square, pre-saved color samples.
Our type tool is still active, so we click and drag our cursor across the invisible word Elaine to highlight it, exactly the same way you would highlight a misspelled word in a Microsoft Word document to change its formatting.
With the invisible text highlighted, we turn our attention back to that grid of squares in the swatches panel.
And here we run into an immediate usability issue. The instructions explicitly tell us to select a very specific color named light yellow-orange.
But as you stare at the swatches panel, you are just looking at dozens of tiny colored squares. None of them have labels. Unless you have perfect encyclopedic color memory, it is completely impossible to know which specific microscopic orange square is officially designated light yellow-orange.
This is a brilliant moment to learn how deeply customizable the interface truly is. The way a panel displays its information isn't permanently locked in.
Every single panel in the entire Photoshop interface, layers, swatches, properties, whatever, features a tiny, subtle icon in its absolute top right corner. It usually looks like 3 or 4 stacked horizontal lines. In modern UI design, this is affectionately called a hamburger menu.
Clicking that hamburger menu opens up the specific panel menu. This isn't a global menu affecting the whole document. It is a highly localized menu that only contains commands for changing the behavior and display of that one specific panel.
We click the hamburger menu for the swatches panel. A list of viewing options drops down. By default, it is set to small thumbnail, which gives us the dense grid of nameless squares.
We move our mouse down and click the option labeled Small List.
The transformation is instantaneous and incredibly helpful. The dense grid of squares completely vanishes. It is replaced by a neat, alphabetized vertical list.
On the left side of the list is a small square showing the color, and on the right side is the actual written-out text name of that color.
Now, the task is trivial. We just scroll down the list alphabetically, read the text labels, find the specific entry for light yellow-orange, and click it once.
The moment we click it, the highlighted text on our canvas instantly changes from camouflaged blue to bright, vibrant orange. We can finally see the name, Elaine.
To finalize the action, we look back up to the options bar and click the small icon that looks like a check mark. This commits the edit. It tells the software, I am finished typing characters and changing colors for now. You can take me out of text editing mode.
The orange text looks objectively great. It pops beautifully against the blue. But let's introduce a hypothetical scenario that happens constantly in professional design.
What if you stare at that orange text for a minute and you suddenly decide you hate it? You decide the camouflage blue was actually a cool avant-garde stylistic choice, and you want it back.
Or worse, what if you accidentally sneezed, hit the delete key, and completely erased the entire text layer?
We have to discuss the most vital psychological safety net in all of digital creation, the undo command.
If you are coming from almost any other software environment, writing an email, using a spreadsheet, writing an essay in a word processor, the concept of undo is deeply ingrained.
You make a mistake, you hold down Control and Tab Z on Windows, or Command and Tab Z on a Mac, the mistake disappears.
You hit it again, the mistake before that disappears. You can rapidly hammer Control+Z and watch your document unwrite itself sentence by sentence.
But if you attempt that exact same behavior in older default setups of Photoshop, assuming it will work exactly like a word processor, you are going to encounter a very jarring and confusing reality.
Historically, pressing Control+Z in Photoshop does not walk you backward in a linear sequence. It only takes you back exactly one single step.
Right. You press Control+Z, and the orange text turns back to blue. That makes sense. But then you press Control+Z a second time, fully expecting the text to disappear entirely because you were walking backward.
Instead, the text violently snaps back to being orange. You press it a third time, it goes blue. Fourth time, orange.
It isn't walking backward. It is violently toggling between the past and the present. It acts like a light switch, completely stuck in a loop of undo and redo.
To a beginner, this behavior feels utterly broken and wildly frustrating. Why on earth would the software refuse to let you step back more than once?
The answer has absolutely nothing to do with stubborn software design and everything to do with the fundamental hardware limitations of computer engineering, specifically regarding RAM, random access memory.
Let's dig deep into this because understanding the hardware constraints completely changes how you view the software.
Think about what happens when you type a sentence in a word processor. A text document is essentially just a string of highly efficient, lightweight character codes. It takes virtually zero processing power.
The word processor can easily memorize your last 500 keystrokes, holding them all simultaneously in your computer's short-term RAM without breaking a sweat. It uses kilobytes of data.
But Photoshop is not manipulating text strings. It is manipulating dense, mathematically heavy matrices of pixel data.
Exactly. Imagine you were working on a massive, highly detailed photograph shot on a professional camera. The file might be 100 megabytes in size, containing 50 different layers.
You select a massive brush and drag a huge stroke of red paint across the entire canvas. That single action might permanently alter the color values of 20 million individual pixels simultaneously.
In order for Photoshop to offer you the ability to undo that brush stroke, it cannot just remember he painted red. It has to physically take a complete, full-resolution mathematical snapshot of the entire document exactly as it existed before you made the stroke and store that massive chunk of data in your computer's RAM.
If you wanted the software to act like a word processor and remember your last 50 brush strokes, it would have to store 50 complete, massive snapshots of your document in your RAM simultaneously.
In the late 90s and early 2000s, computers simply did not have the physical hardware capacity to handle that. If the software tried to save 50 history states of a large file, it would instantly devour all of your available memory, grind the computer to an absolute halt, and inevitably crash the entire system.
So the engineers had to make a brutal compromise. To protect the stability of the entire computer, Photoshop's default behavior was hard-coded to be incredibly stingy with memory.
It was intentionally designed to only hold one single snapshot in its short-term buffer for that quick Ctrl+Z toggle. It was a self-preservation mechanism for the hardware.
Now, to be clear, the software wasn't entirely unforgiving. They built a separate command called step backward, often mapped to a slightly more complex combination like Alt plus Control plus Z or Command plus Option plus Z.
This command explicitly told the software to dig deeper into the history panel, a separate system that logged multiple states, though even that was strictly capped by how much hard drive space you allowed it to use as virtual memory.
Modern computers obviously have vastly more RAM than machines from 20 years ago. You can now configure modern versions of Photoshop to allow the standard Ctrl+Z to step backwards sequentially, acting much more like a modern application.
But understanding the intense hardware-level logic behind that original single-step toggle is fundamental. It teaches you to respect the sheer crushing volume of mathematical data the software is silently processing every time you click your mouse.
It isn't a word processor, it is an industrial-grade pixel engine.
And we respect that engine by moving forward. We use our undo and redo to confirm that we definitely prefer the orange text. Our final task in constructing the card is layout.
The name Elaine is currently just sitting randomly on the left side of the blue ribbon. It needs to be perfectly centered to look professional.
We travel all the way up to the absolute top of the Tools panel and select the Move tool. Its icon is universally understood, a cross composed of 4 arrows pointing in cardinal directions.
We hover our cursor over the orange text, click, hold the mouse button down, and physically drag the word toward the center of the ribbon.
As you drag the text horizontally across the canvas, you will likely experience a sudden visual interruption. Bright magenta lines will suddenly flash into existence, slicing across the image, and the text you are dragging will feel like it magnetically snaps or jumps into a specific position, almost pulling itself out of your control.
Those flashing lines are called smart guides. They represent an incredibly complex algorithm running continuously in the background.
As you drag an element, the software is desperately trying to anticipate your intentions. It constantly calculates the position of the text relative to the geometric center of the ribbon, relative to the edges of the canvas, relative to the rose petals, trying to find mathematical alignments.
When it calculates that the center point of your text is perfectly aligned with the vertical center axis of the blue ribbon, it flashes the magenta line as visual confirmation and magnetically snaps the text into that exact mathematical coordinate.
It is designed to ensure perfect precision without requiring you to manually draw rulers and grids.
And in theory, that sounds amazing. But in practice, I have to push back heavily on relying entirely on smart guides. Yes, they help you center things, but they can also be violently aggressive and deeply annoying.
In what way?
Because design isn't always about perfect mathematical alignment. It's often about optical alignment, how things actually look to the human eye.
Sometimes you have a piece of text that you just want to nudge a millimeter to the left because it visually feels better balanced against an asymmetrical background element.
But when you try to gently drag it, the smart guides panic. They grab the text and violently snap it to the edge of a completely unrelated element, like the stem of the rose, because the math says they align.
You end up wrestling with the software, fighting its magnetism, just to place an element where your eyes tell you it belongs.
That is a very real frustration, and it highlights the difference between software assisting you and software overriding your judgment. Fortunately, there is a built-in override.
If you are dragging an element and the smart guides start snapping erratically, you simply reach down with your left hand and hold down the Control key on Windows, or the Command key on a Mac.
That modifier key is a revelation. The moment you hold it down, the algorithm is temporarily suspended, the magenta lines vanish, the magnetism completely shuts off, and your mouse movement returns to smooth, analog, free-form control.
You can place the text exactly where you want it, down to the individual pixel.
It is the digital equivalent of turning off the automatic traction control in a high-performance sports car because you want to feel how the tires are actually gripping the road. You take the control back from the computer.
We hold the modifier, we perfectly center the name Elaine optically, and we release the mouse. At this point, the core project, the birthday card, is structurally complete.
We've navigated space, manipulated lighting non-destructively, sampled colors from reality, drawn geometric boundaries, added typography, and managed our layers.
But the chapter doesn't end with a finished file. Before we close out, the text takes a significant detour to teach us how to truly command the environment we've been working in.
Because as your projects grow more complex, those panels on the right side of the screen can quickly turn from helpful organizers into an overwhelming, cluttered nightmare.
We need to talk about panel management. It is a critical survival skill. The book demonstrates a series of escalating maneuvers to reclaim your screen real estate. Let's start with the most dramatic, the nuclear option.
Imagine you have been working intensely on color correcting a tiny detail for 2 hours. Your screen is covered in floating swatches panels, complex layer hierarchies, and expanded properties windows.
You just want to lean back and see the entire unencumbered image without any interface distractions whatsoever.
To do that, you don't individually close every panel. You simply press the Tab key on your keyboard. It is a brilliant instant toggle.
The moment you strike Tab, the entire interface evaporates. The Tools panel on the left vanishes. The Options bar at the top disappears. Every single panel on the right is gone.
You are left with nothing but your artwork floating against a dark background. You can assess the design in pure isolation, and the moment you want to get back to work, you press Tab a second time, and the entire complex interface instantly reappears exactly where you left it.
It's an essential quick preview mechanism, but usually you don't want to hide everything, you just need to tidy up a specific area. The panels on the right side are docked together in columns, but they are completely modular.
If a specific panel, like the Properties panel, is taking up too much vertical space, you can simply double-click its title tab.
The entire panel instantly collapses upward, rolling up like a window shade, leaving only the thin title bar visible. Double-click it again, and it expands back down.
If you need to focus intently on your layers hierarchy and want it right next to your artwork, you can click the Layers tab, hold your mouse button, and literally drag the panel physically away from the dock on the right.
It tears off and becomes a free-floating window that you can position anywhere on your screen. You can then grab its bottom corner and stretch it out to be incredibly long, allowing you to see dozens of layers simultaneously without scrolling.
And if you're working on a severely restricted screen like a small laptop on an airplane tray table, you can reclaim massive amounts of horizontal space. Look at the very top of the right-hand panel dock. There are 2 tiny right-pointing arrows.
If you click those arrows, the entire massive column of complex panels instantly collapses horizontally. It shrinks down into a single, thin, vertical column consisting of nothing but tiny icons representing each panel.
You gain back perhaps 20% of your horizontal canvas space. When you need a panel, you click its tiny icon. It briefly flies out so you can use it, and then it automatically collapses back into an icon when you click away. It is hyper efficient.
The overarching lesson here is that the right side of the screen is not a static wall. It is a fluid, customizable workbench that you are expected to rearrange constantly based on the specific task you are performing in that exact moment.
And that customization extends beyond just moving panels around. It extends to the fundamental aesthetic of the application itself.
The text concludes by showing us how to alter the actual environment. If you navigate to Edit Preferences interface on a Windows machine, or Photoshop CC Preferences interface on a Mac, you access the core visual controls.
The most prominent setting here is the color theme. By default, modern Photoshop boots up in what is essentially a dark mode. The canvas is surrounded by a deep, dark gray interface, and the panels are dark gray with light text.
And why is that the default? Is it just an aesthetic trend to make it look pro?
It goes much deeper than aesthetics. It is rooted in physiological ergonomics. Professional retouchers and designers often stare intensely at these monitors for 10, 12, or 14 hours a day.
If the interface surrounding the image was stark white, it would be the equivalent of staring directly into a glowing light bulb all day long.
It causes massive compounding eye strain and severe visual fatigue. A dark interface significantly reduces the overall ambient light blasting into the user's retinas.
Furthermore, from a color theory perspective, a dark, neutral gray background removes visual competition. It prevents the interface from influencing how your eyes perceive the colors in the actual photograph.
It allows the vibrance of the image to stand out cleanly against the neutral void.
Exactly. However, the software engineers recognize that human preference varies, and lighting conditions change. If you are working outside in bright sunlight, a dark interface might become impossible to read due to screen glare.
In those interface preferences, you are presented with 4 distinct color swatches ranging from nearly pitch black to a bright light gray. Clicking the light gray swatch instantly transforms the entire application, reverting it to the classic bright interface style that dominated the software throughout the late 1990s and early 2000s.
It's a fantastic touch of total personalization. It changes the mood of the room you are working in.
Which brings us to the natural conclusion of our deep dive into Chapter 1. The textbook format always provides a structured review Q&A at the end of the chapter to solidify the learning, and we should synthesize those core concepts to ensure we fundamentally map the territory.
Let's run through them. The first structural concept. What types of images can Photoshop actually handle?
As we deeply analyzed, while the software possesses rudimentary tools for plotting vector graphics and text, its absolute primary domain, its engine room, is dedicated to manipulating bitmap digital images.
It is built to organize and alter the millions of tiny square pixels that make up continuous tone photographs and scans.
The second core concept dealt with managing the sheer volume of tools. How do you select hidden tools? You don't panic when you can't find something.
You look for the visual cue, the microscopic triangle in the lower right corner of a tool icon. Once you spot it, you either click and hold the mouse button to reveal the flyout menu, or you use the much faster modifier trick, holding Alt or Option and clicking the icon to cycle rapidly through the hidden group.
It is how the software balances extreme capability with manageable cognitive load.
And finally, the mechanics of observation. What are the distinct ways to zoom and navigate? You can use the traditional zoom tool and click mechanically. You can hold Alt or Option to zoom out.
You can draw a highly specific marquee box to teleport to a detail. You can use the incredibly kinetic, fluid motion of scrubby zoom to tie the magnification to your physical hand movement.
Or when you are completely lost in the microscopic details, you can rely on the navigator panel, dragging the red viewport rectangle around the minimap to instantly pan across the massive canvas without losing your overall orientation.
It is a remarkable progression. We began this discussion feeling intimidated, comparing the interface to the hostile, uncompromising dashboard of a commercial airliner.
Right.
We assumed that the software was rigid, demanding that we adapt to its confusing layout.
But the journey through these fundamental steps reveals the exact opposite to be true.
If there is one overarching philosophical takeaway to internalize from this entire foundational process, it is this: a professional digital workspace is not a prison. It is inherently deeply modular.
By learning how to drag layers, dock swatches, collapse complex panels into icons, and fundamentally change the color theme of the environment, you aren't just learning rote software commands.
You are actively acting as the architect of your own custom digital studio. The tool is explicitly designed to mold to the eccentricities of the user, not the other way around.
You start by surviving the interface, but you end up orchestrating it. The intimidation fades completely when you realize you hold all the control. The moment you stop fearing that you are going to break the software, the real, uninhibited creativity can finally take over.
That is the threshold every professional must cross.
And that feels like the perfect place to wrap up this deep dive. As a final reminder, if you want to follow along with this curriculum and master these specific architectural tools yourself, please check the description for the QR code and the direct link to buy Adobe Photoshop CC Classroom in a book 2018.
Having that structured text in front of you while you navigate these menus for the first time is an absolute game changer.
The structured visual context completely accelerates the learning curve.
It really does.
And please, make sure to follow for more technical design breakdowns and career-building content just like this one. We are absolutely dedicated to helping you turn that raw ambition into precise professional execution.
So get your software booted up, reset those preferences, find your absolute favorite hidden tool, and go out and construct something entirely new.
But as you do, ask yourself this one final question. Now that you truly understand that you have the power to tear down, rebuild, and customize every single microscopic aspect of your digital environment, what does your perfect, ultimate creative studio actually look like?